Welcome to qnawire.
So in this case, what we're going to have is iron 304, which is going to be magnetite, over here like this. Sorry about that. Iron 304. And the first thing that we want to know is what is going to be the ratio of iron 2 plus with iron 2 plus in this compound. So remember that the oxygen is going to count each of them with a charge of -2. So the total charge is going to be of -8. So we want to know iron x times 2 plus. What we want is what is going to be the ratio x and y corresponding for this in order to cancel the -8 charges coming from the oxygen. Remember that this compound needs to have a charge equal to 0. So the ratio is going to be x equal to 2 and y equal to 1. Sorry, the other way around. Uh, X equal to 1 and y equal to 2. This is the only combination that is going to give us a final value equal to 0. So in this case, we can write down iron 304 as iron 2 plus with iron 2 of iron 3 plus and O4 with the -8. You can verify that this is going to be 6 plus 2, 8 minus 8 equals 0. So the ratio is going to be from iron 2 plus with respect to iron 3 plus, we're going to have a ratio of 1 to 2. Now for B, we want to state the type of spectroscopy that could be used to determine their relative abundances. And in this case, there are going to be two techniques that are going to be relevant to us. The first one is going to be Mossbauer spectroscopy, which is going to be based on the Mossbauer effect. This is going to be written as Mossbauer spectroscopy. And another common technique is going to be X-ray absorption spectroscopy. In this case, the one that is employed the most is going to be Mossbauer spectroscopy to have the relative abundances for each of them. And finally, for C, we want to get the number of protons, neutrons, and electrons on each of the species. So for that, we're going to get that for iron, we're going to get iron 2 plus and iron 3 plus, the number of protons, number of neutrons, and number of electrons is going to be the following. First of all, remember that in the case of iron, we can represent this as iron 56 with an atomic number of, this is going to be iron 56. This is going to be the most abundant one, isotope that we're going to have. So the number of protons in both of the cases is going to be equal to 26 because this is given by the atomic number. The number of neutrons is equal to the mass divided the mass subtracting the number of protons. So in this case, it would be 30. And the number of electrons, since we are going to have a 2 positive charge, we are going to have 2 less electrons in this case, 24 electrons, and in this one, 23 electrons.